Alrighty. Hello, everybody. Today is going to be a very down to earth and very chill kind of stream because we had a recording session yesterday where Tim and I were playing games all day long. My voice is destroyed. I sound like a weed whacker that's out of gas. So, we're going to keep things fairly simple today. Keep it on the down low and see if we can come up with some interesting stuff. Okay. I'm going to make a fern. And we're going to see if we can make it interactable. And we're going to see if we can make it interactable by using multi-mesh instances. I think this might be an interesting thing to experiment with. So, pen. Yes. Beautiful. And I think that's the brush I want to be using. No. That's the brush. Okay. Maybe this is the most overcomplicated shape that I decided to go for in terms of a fern. Uh, this would be entirely unnecessary. At least not for the first one. Okay. Let me see if I can lower the stable. Okay. Okay, we need to make sure that the shapes don't overlap, at least horizontally. There we go. Okay. I don't know what I'm going to have up there, but I suppose we'll find out. Hey, top indeed. Today's kind of a weird day. None of my usuals are popping into the chat, but I think YouTube is pushing it out to randos. So I guess today we're gonna see a bunch of new faces. Oh yeah, hold on a second. This is the wrong brush. This is the pixel art brush, which essentially has a bunch of stuff in it, a bunch of strict, harsh textures, and we don't want any of that. None of this project. Okay, let's save this. Assets, textures, foliage. Fern 1, even though technically it's not a fern. Whatever, that's fine. This has to be a PNG. Okay. We're going to load up the texture. Mm-hmm. Okay. We can't really see the alpha data because we got to connect the alpha channel. That's more like it. Okay. Beautiful. So, okay, so this right there might be the first problem. Let's see. Yeah, this is going to be a problem. I guess maybe dividing the whole component into multiple shapes would help. Or multiple grid elements. Yeah, okay, I should have checked it using the rulers first. I think we can move this stuff. Hmm. Actually, if I move it up here, we can get away with it. Unfortunately, we can't move multiple layers. Okay. There we go. What in the heck? What kind of language is that? Hold on a sec. Ah, Abend means evening. German fellow? Okay. So we can... Whoops. Ah, come on. Nice. All right. Okay, we want to go only with connected objects. Right? Nice. We're going to set the transforms take place around the axis. Okay, I think that could work. Maybe we even gone a little overboard. Okay. Hmm. Interesting. Okay. This might be it. Like, I don't think we need any more. Okay. Leave this out. Save this. This is going to go to Child of Ether, Assets, Models, Foliage, and it's going to be Fern. Cool. All right. This one we can just join it together. Shade Smooth for good measure. And cool. All right. Export OBJ. That's all that we need. Selections only. No materials. Engine. Models. Furniture. Burn. Cool. All right, hold on. I need to close this. All right, so here's the deal. We technically want to use the multi-mesh instance-based generator here. So we duplicate it. We make the shape unique. I believe so. And then grass multi-mesh. What is this scene? Multi-mesh auto placer. And what is this one? Multi-mesh auto placer. Okay. That's fine. So we go here. Let's bring this thing over this way. Actually, let's pop on over to what's his face? Where's his face? Right here. Reset rotation. Then the multi-mesh we want this thing to use is going to be unique. And I think we might have already screwed it up by moving him over here. Okay, so quick load. Burn. Beautiful. Almost jungly-like. Let's give it a surface. Quick load, fern. There we go. Now, transparency. No, not that kind of transparency. We need alpha scissor. Yes. Mm-hmm. Now you may notice that every single one of these ferns is rotated the same way. Now, we haven't done this in this project, but I have added additional features like random rotation. Okay. So we do it like this. And then when we figure out where we place, we have randomized multi-mesh. This is where we choose a random position. We have an instance basis that we make scaled, but we also need to do another transformation. Rotate it. There we go. Hello, what's your day job? I teach programming. Programming and game dev. Okay. Let me double check this. Basis. Can I click on you, please and thank you? No? Apparently not. Okay. So basis is relative to each instance. So we should be able to do rotated, and we give it an axis and the angle. Okay. So vector 3, rotate it on upwards axis, and then range, random rotation X, random rotation Y. So X and Y gives us, this is the X and this is the Y. We're just using it as a random range amount. Vector. Okay. And I believe now this should give us the ability to randomly rotate these things. Now, something I discovered is when we randomly position the ferns, we risk losing the arrangement that we might have generated. So like, oh, this looks like an interesting distribution of objects, but as soon as we change anything about it, it regenerates it and we lose it. So one thing that we can employ here is the use of a fixed seed. So we can do seed. I believe it's just seed. Yes, and it accepts an integer. So I guess we can make a seed val variable, make it an export, set it to, I don't know, 0 for starters, and then there we go. We might have an error. Do we have an error? We don't. If I set seed val to 1, gives us a different seed. But then as you can see, it doesn't change if we regenerate, which means now we will never lose a particular arrangement, and the seed should be the same between games. Hopefully. Okay. Now we can reduce this. 5,000 might be a bit much. Okay. There we go. That's 300. We can't see half of them because they're too small. Like right there. And it's also inside out because our material needs to be made both non-cold. There we go. Beautiful. And I believe one of these is also the grass multi-mesh. There we go. So we can increase this. 1. If allocate index extends on base null instance. Right. Now, it should be able to accept the shape just like that. And then we could just extend it this way. Right, 50 by 50. 20 by 20. Eh, sort of. Oh, nice. Now, whenever we change the grass size, it doesn't update it, but we can make it be updated by giving a set get. And then running the generate or randomize multi-mesh function. And then the set get needs to be actually told that this is the set function. Okay. Cool. Also, it has editable children, but hypothetically we don't need that because we're just setting the region using this property now. Okay, so now if we change the scale, you can see everything already gets updated, just like when we move this thing around. Okay. Cool. can we make it update when... Okay, here we detect when the shape extends changes. That's fine. We technically could work without a shape extends, because, well, the whole purpose was to see a collision shape. But clearly we cannot see the collision shape unless we actually make, click on editable children and see set the collision shape to be visible there. So if that's the case, if we're just typing in the number, do we even need that shape, realistically? We might not. It has collision shape inside, but we're just using it as a surrogate for number entry. So using the extends, checking if the box has changed sizes, and then you only using X and Z. So I suppose we can do rect region. It is going to be equals to a vector 2. Let's do 30 by 30 by default. I think it was a bit over-engineered last time. So set shape was used in order to, well, it was used in order to update the collision shape, but again, that collision shape is just a surrogate for a size selector. So we can make away with this and instead use set shape here. Let's call it set region rect, or rect region. Okay, so it sets the new shape and then runs the randomized mesh, multi-mesh. Cool. So now we need to go through this. Okay, physics process. If it's null, return. That is no longer a thing. Randomize multi-mesh. This is for detecting if the shape has changed, which we don't need to do anymore. We're just going to do it using the setGet function that watches a variable for changes. Okay, so now we got to get to here. Instead of collision extends, we use the variable right away. Technically, in this case, we're going to have to use y because we use the vector 2. Okay. I believe that's it. Let's see here. Okay. Seed. All right. Everything changes. So this means we don't actually need this collision shape anymore. Yes, it is going to mess up a bunch of grass that we've placed earlier, but that is okay. It's not a big deal. Maybe we can get a set get on the seed as well. There we go. So now your code looks hot. Well, thanks. Appreciate it. So now if we update the seed, you can see that it randomly generates everything. And if we just take a moment to enable everything, Yeah, nice. I like it. Jesus Christ, I sound like a chain smoker. Oh, yeah. That sucks. Go check out Retroactive Gamers YouTube channel for the reason why this happened. This is actually looking pretty good. It's a wonder how much just adding a little bit of foliage adds to the whole scene. And then maybe we can also do something about changing this rotation value. Set get random rod set. We're gonna push and then randomize multi-mesh. Ooh, okay. There we go. Okay, so now we should be able to do this. And it does nothing. Okay. Wait. That's the grass. That's why it doesn't do anything. We need the ferns. There we go. So we set it to 0. Every fern points in the same direction. Same exact angle. Nice. Okay, now. The whole point of doing this was so that we could add a little bit of motion when the player passes through each of the ferns. So we're going to basically be making a shader, a custom shader. So I guess we're just going to override it. Shader material. Let's give it a... What shader is it going to be? I think we can try it with the visual shader. Okay. Now, if we go to visual shader and then add... Oh, geez. Let me select it. Textures, foliage, fern 1, send it to albedo, and then here, this is color data, and for the flags, we need to use nothing. No back killing. There we go. And then alpha scissor, we need to attach a float or scalar. Scalar constant. Okay. All right, and alpha, I think we need to connect. There we go. Nice. Okay. Now we need to make this stuff kind of wiggle and offset. So we're going to switch to the vertex shader. Let's add time. And we're going to need to give it a texture for a noise. Okay. Texture uniform. We should now find this if we back up here. Should be able to find this here. Shader. Oh, well. I guess we haven't connected it, so it's like, yo, man. We don't need this. Let's back up. Yeah, there we go. So now we can give it a noise. Godot has some noise generators of its own now. noise, open simplex noise. Sure. Seamless. And the rest is fine. Let's take a look here. Can we see it? Nope. Okay. Fine. Okay. I mean, it would be nice. Oh, yeah, we do see it. There it is. Okay, so we are going to be taking the vertex data. Oh, well. Excuse me. Taking the original vertex data and then adding some vertex offset to it based on this noise map. Okay, so I guess we could just do this. And then this goes here. Okay, and that's what it looks like. It's kind of messed up, but it is what it is. Why do you develop multiple projects at the same time? Wouldn't it be easier to develop and finish one by one? So, in theory, yes. In practice, how long can you do the same thing before you get bored of it and just completely, like, sink in hours and hours and hours on end to the point where you just can't look at it? You need variety, right? You need some sort of variation in your life. So I work on multiple projects because it's a way of cheating by doing something that isn't the project, but still working on the project. So productively putting my time into something that, has equal result or equal opportunity for success, so to speak. Right? Because I've done the whole spend all my time on one project. It sucks. It's fantastic when you're like full of ideas, but when you hit that wall, when you hit that burnout and you hit that wall, oh, it sucks. And what helps me is to do something else. And if it's something else, it might as well be a different project. Okay, we're going to make this offset move. So I'm going to take vector. I guess what do we need to do here? We need to add to the vector data, or to the UV data, I should say. We're going to add a vector. It is going to be composed. So we're going to build a new vector. And then one of those values is going to be the x value. And then we'll just shove it in here. And then we end up with this. Okay. Now, a way to mitigate this, first of all, is by slowing it down. So we're going to multiply by 0.2. Okay, nice. Next, we need to increase the dimension of this noise texture, which is by modifying the UVs. So we're going to multiply only X and Y. There we go. So now the detail is much more subtle. Next, we need to tone down the amount of this effect. As a matter of fact, I think we might want to go even smaller. There we go. So you see the whole leaf acts as a one big thing. Now, what's curious is that everything moves at the same time, which kind of makes me think, oh, that makes sense, because every single fern shows the same exact texture, and it has the same exact UV. So that's why they're all dancing at the same time, because they're all basically showing the same texture data. Now we can offset it by using the vector or the vertex position of each 3D object to offset. I suppose we can offset the texture space. So we'll take this vector, insert it here, and then we'll take the vertex data and offset it, and then feed that in here. So it doesn't look like they're all doing it at the same time anymore, but you know, it's not exactly great. It added the vertex data to everything. Maybe we need to tone down, so like multiply this by quite a bit. So 0.1, that is, so reduce it. Okay, there we go. So you can kind of see that it's no longer all at the same time, although it's kind of still looking like it. Okay, we need to tone down the amount of distortion we're doing here. So let's take this, multiply, 0.2, 0.2, 0.2. Okay, nice. And then one final thing. We don't want the bases to juggle as much. So what we're going to do is we're going to create a mask. It's going to be a mask consisting of a series of gradients. And where there's black, there's going to be no movement whatsoever. And where there's white, which we don't see white yet, there we go, we get to see most movement. So I'm just going to keep it at reduced transparency. I'm going to lock the guides. Okay, I'm going to make it black. Yeah, there we go. That's the idea. Oh yeah, I had grow enabled also. Don't want that. Okay, I'm going to export this. This is fern1 mask. Okay. Also, before we do that, gotta bring it back. There we go. Okay, so we're going to do the following. We're going to take that mask, and then we don't need to change anything beside it. We quite literally just need to multiply the output from here by this, and then feed that to the... And there you go. Okay, now everything is moving kind of still more or less in synchrony. I think maybe by adjusting the noise texture, we can adjust it. It doesn't really update the preview unless we click on it. So as you can see, this increases the dimensions. And then, what's persistency? I think that's like how much detail is in there. Oh, yes. And as you can see, so it's cool. It's got a tiny bit of a delay, but it's not quite there yet. Well, that's really subtle. Interesting. Okay. Change the seed if we need to change the type of noise. That's really cool. Okay. And noise offset. All right, let's get back in here. So, what do we need to do now? Well, realistically, the whole point was that there's ferns, and then when we walk through them, it causes them to wiggle a little bit. Now, this means that we have to somehow make it effectively generate a method of detecting if we are walking through them. I'm going to do this. I'm going to position the player here. Nice. That's cool. Did we bring back the randomness in the rotation? No, we did not. There we go. Beautiful. And as you can see, moving around also is a lot smoother because the seed is predetermined. Okay. So here's the idea. How do we go about assigning a different value to each of these ferns and just making it so that we can detect when one of the ferns is being walked over? Well, the detection part of the player is very simple. You just use the area node, and within one area node, you can actually use multiple collision shapes and just detect which collision shape was it that detected the player walking over the fern. But then how do we communicate this data to the fern? You see, in GameMaker Studio, you have this really cool thing where you can pass along an array of data into the shader. In Godot 3, that is not a thing, but you can pass along a texture and then use that texture as a pseudo array of data. So in that case, here's what we can do. We can have the player walk over a fern, detect that by an area node, and then write a pixel to a texture. And then whichever fern is responsible for that particular pixel is going to be the one to wiggle around. Now, the first thing we need to do is we need to figure out how to actually determine which fern is the one that is, let's say, supposed to wiggle. Not even the one that we touch, just the one that we're supposed to wiggle. So the multi-mesh has this feature called custom data format and color format. Format of the colors in color array that gets passed to the shader. So essentially, I believe that the multi-mesh is capable of assigning a custom piece of data in the form of a color to each instance. And then we can use that color, which is basically just 4 8-bit values, in order to identify a particular fern, which is creative on their part. I guess it's better than nothing. So we're gonna see about like getting the shader, and we have to do this within the shader. We don't want to keep updating the multi-mesh with this nonsense. So we have to do it within a shader, and I suppose now we have to take a look at the multi-mesh function. I think my hard drive just opened. That's fun. On the second computer. Instances are too far away. Blah, 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 yada, yada, yada. Okay, this is curious. Get AABB. Get instance color, and then we could do set instance color. Okay. Sets the color of a specific instance by multiplying the mesh's existing vertex colors. For the color to take effect, ensure the color format is non-null on the multi-mesh. Okay, well, that's interesting. And it says use vertex colors as albedo is true, which we don't want to actually use the color or see the color. If the color doesn't look as expected, make sure the material's albedo color is set to the pure white 111. Set instance custom data. Sets the custom data of a specific instance. Although color is used, it is just a container for 4 floating point numbers. So we got 4 floats that we can assign to each instance. The format of the number can change depending on the custom data format. So that's here. Either byte or float. I think I want to work with a byte. But if it's a byte, then it's only like 220, 255. That's the maximum value. If the color doesn't look as expected, oh, no, that's here. Okay, so even though it sends the color value, if we join the 4 values together, we get a nice 32-bit integer, which coincidentally is the limit of how many instances we can place. 32-bit integer, the maximum number. So I suppose, what can we use here? 255 times 255 times 255. Okay, 16,000. And yeah, okay. Yeah, wrong math. Oh, wait, hold on. There's 4 values. Yep, there we go. Almost. Is it 255 or 256? 256 is how many values? Yeah. Okay, there it is. Yeah, so when you send a color value, it sends RGBA right here. RGBA, so 4 8-bit integers. Hmm. So I suppose on the shader side, we will take the individual values, multiply them together. We just have to make sure that when the player walks over a particular mesh, a particular collision shape, it accurately marks the color values or the 4-bit 4 color values RGBA in the right order. Okay. Which is honestly kind of curious. How would we go about ensuring that, let's say if you do like 0 0 16 0 or 0 0 0 16, or I guess we got to do like 1, because then everything is just going to end up as 0. So these, both of these result in the same exact number. If we multiply 1 by 1 by 16 by 1, or 1 by 1 by 1 by 16, it just all results in the same exact number. So, but that doesn't quite make sense, because we have to be able to differentiate. This is one fern, this is another fern. So can shaders do bitwise operations where we can just push a byte over, like shift it into another byte? I guess that's the question. That's the grass. We need the ferns. Let's take a look. Bitwise? No. I guess this would be like an operator. Just scalar op. Power, remainder, divide, multiply. Although, hmm. You take the first number, 255. Second number, 255 times 1000. Then third number, 255 times million. And then 255 times billion. When we multiply all of these values together, every 255 value is shifted by 3 digits. So, but it still kind of represents like a, yeah, no, that's stupid. It's like decimal representation of a binary value. What the shit is this? Okay, so, we could say it's just 255 plus 255? No. Interesting. There's no comparisons because there's no logic in shaders. Divide remainder. 1 minus, truncate, round even. Okay, well, this is where, if I knew math, I'd probably be able to use one of these, or a series of these. Yeah, well, that's why I gotta brush up on math. So, what can we use? I could use just the one value, for starters. Maybe modulus? If I do like... So modulus of anything... Okay, so doing modulus on anything that isn't the same value is going to result in a different number that isn't a 0. So let's say it's like 95 mod, and then the target fern is 80. So that's 15. We don't really care that it's 15. We just care that it's not 0. Can we get a sign? We can get a sign. Okay. Now, what is the sign? What is the sign of 0? I believe the sign of 0 is going to be positive. Let's see. Okay, I know that there's a built-in sign command, but there's also a sign in the shader. Hmm. I think this is GG script. Oh, no. Try playing a shader. Hmm. Okay. Well, I mean, that's cool and all, but we still have no idea how to get the data. I believe that, let's see. Okay. Multi-mesh Godot instance. Okay. Set instance custom data. This custom instance data has to be manually accessed in your custom shader using instance custom. Okay, we have an input. We have vertex normal, tangent binormal, alpha world camera, projection, inverted projection, and right. Okay, so don't have it here. What else do we have? Color constant, color uniform. Well, color uniform is for inputting a number. Point size, tangent, vertex. Yeah, okay. And there's a, maybe, vertex color? Maybe. Okay, let's try something limited. So let's take, in the input, do I have vertex color? Not here. Okay. Color. Okay. There's actually a description. Color input parameter for the vertex and fragment shader models. Cool. That's fine. Now we will have to actually set the color. So set instance color. So we're going to be using this one instead of this one. I would like to use this one, but I guess we just need something. So let's go in here. And then when we get an instance, here's the for loop. Set instance color. So we're going to do each instance in the range of how many instances we're doing. The color is going to be, we're going to keep it limited. It's going to be, let's do this. Var C as in color R starts at 0. And then we're going to do color R. And then to color R, we're going to add +1. Okay. And then I think once we reach 255, then it's going to be 0, 0, 0, 0 for the red, green, for the green, blue, and alpha. So once I reach 255, I don't actually want any colors at all. So we're just going to do this. And then what is it that actually needs this instance? I think it's a multi-mesh. Okay. And come on now. There we go. Okay, so we go here. Now, technically, to verify that this worked, I can go into the shader, and I think I can do like what? Use sRGB, which we might not actually have it here because this is not a spatial shader. So I can just do this. Oh, are vertex colors not available here? Vertex, no, that's the coordinate. Fragment color. Hmm. Hmm. Interesting. Vertex lighting. Oh, well, hello. Use world vertex coordinates. That seems like helps us with the proper offset. I think that's good. Okay, but what do we have here? Skip vertex transform, depth test. Interesting. So, I guess no way to verify. Passing values from vertex to fragment. Vertex shader can write output to varying variables, which give you values for each vertex. Okay. You know what? That's fine. Let's make an assumption that it did write the vertices. So that means, whoops. So that means right now, all the ferns have different vertex colors. We can't see them, but let's assume that they're there. Okay. So this means that if I were to go to the shader and I would use vertex color, that's vector 3 color. That might be it. Yes. I would use the vertex color, which actually I think that's exactly what we need here, isn't it? Fragment color. Color input parameter for the vertex and fragment shader model modes. Maybe. Nope, everything is just white. But I also don't think that that's actually the color, the vertex color. Okay, that's fine. So here's what we'll do. So we have the place where we multiply this. If it's 1, 1, 1, like this, you can see how it's kind of like super stretched. And if it's 0.2, 0.2, 0.2, okay, you know what? Maybe what I want is something that moves really quickly. Right, something that moves really quickly, which is something based with time, which is this guy. Okay. So let's say we'll take the color and then we can compose. Yep, we're going to use the X value, which is RGB A. Let's make an assumption. We do this. Are any of them really fast? Doesn't seem like it. They're all just kind of moving at the same speed. I guess we need to multiply this by 1 and this by 1. Doesn't really seem like... Yeah, it doesn't really seem like any of them are... Yeah, I don't know. Doesn't really look like it. Oh yeah, this is a vector value being multiplied by... Ah, jeez. Okay, that's got to be decompose. Hold on. And then we'll take the x, multiply it here. Okay, so everything's kind of moving seemingly at the same speed. Okay, so it clearly said instance custom. Okay, so dot shader, visual shader, instance custom. But that's only through the code, isn't it? Okay, well this sucks. I think that might be only code. So we would have to convert it to this, which is, yeah, that looks like a mess. I don't think it has it. Okay, well, you know what? We will just leave it as it is. And maybe we don't do it today. I got a fern. I got a shader. I got an error. What's happening here? Direct space state on null instance. Why are you complaining about this now? I'm trying to run the game. Get world. Direct space state. Okay. We have a world. We can use a command. No command. Okay, why are you complaining now of all times? Let's get rid of this for the time being. Yeah, okay. Drag space state to null instance. So that means get world fails to get the world. What do we run get world on? Returns the current world resource this spatial node is registered to. And where do we run this on? Spatial. Multi-mesh instance is inherited from spatial. Right. Navigation mesh instance. Maybe not. Yeah, it is. Spatial, right there. So what the hell are you talking about? Maybe it's another node. It's not this one. Although, you know, there's only one node here that's running multi-mesh scatter code. Let me try this. Close this and that. Go to the level. Oh, well now. Invalidate index direct space state, right. So what happened to the texture? Material, what the heck? Oh, my shader got fucked. That's great. Gotta love that. Jeez. Does it run at least? No. Okay. Is it because it needs to run as a part of the game? Well, no, not really. Maybe it's because... Hold on. Let's try this. Can you get the owner? Expected, right. Okay, so this should tell us who's causing the crash. Object null. What? Hold on. Let's try that again. Okay. Fail on nothing. Apparently nothing is causing the crash. It has no name. Are you actually kidding me? Self, comma, name. Multi-mesh instance 4734. Okay, so which one's 4734? And we can't even see here because it crashed. Hmm. Yeah, okay. Okay. What if we do this? As stupid as it is, let's see. Just reloading the engine. Okay, let's see. Run. Yeah. Direct space state on null instance. Only available in the physics process loop. That being said, for consistency, bullet physics should be returning null 2. Okay. Okay, I don't want C#. Okay, so physics direct space state 3D. Cast array. Okay. So maybe we gotta do this in the physics process. Just get it here. Okay, and then when we do reposition multi-mesh, or I guess when we do generate, yeah, we're just gonna do if this is null, return. I suppose that would make it not work at all, because it only does it once. May or may not have to use... Oh, okay. Well, it did something. Well, actually, hold on a second. Whoa, 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 whoa. Shouldn't this only run in the editor, not in the game? Randomize multi-mesh. So we do if editor is, or engine is editor hint. If not, return. So don't run this unless this is run in the engine. So in that case, we don't need this. Okay. Okay, what's this? Is editor hint is a method, I think. Nope. It's a method in Godot 4. Okay. Well, I mean, the ferns are there. Let's see if it keeps it, though. Oh, there we go. Fairly empty besides the one fern next to the player. That's good. Well, let's see if it works. Yes. There we go. Okay, you know what? It's fine. We'll figure out the whole vertex thing some other time. That's going to be it for this one. Thanks for watching. Continue in the next one.